Hey, fellow mathers. Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam-packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over $6,000 worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians. Welcome to the podcast where math is figure-outable. I'm Pam Harris.
And I'm Kim Montague.
And you found a place where math is not about memorizing and mimicking, waiting to be told or shown what to do, but it's about making sense of problems, noticing patterns, and reasoning using mathematical relationships. We can mentor students to think and reason like mathematicians. Not only are algorithms not particularly helpful in teaching mathematics, but rotely repeating steps actually keeps students from being the mathematicians they can be. What are you doing in the background?
I'm sorry.
I'm like, are you walking around?
No. I just hit my glass of water, and also I was thinking about what day it is because we're gonna be traveling super soon. Like, I don't even know what day you go, but it's almost time for conferences.
Woo!
All right.
Have fun.
I know. Okay, so hey, we got a review. I don't know. I hate calling them a review when it's somebody's just like sharing their story. So I don't know.
Okay.
It's a share. Anyway, but the title of it was longtime listener, first time reviewer. I don't know. Do you leave reviews like Yelp or whatever? I never do. Ever.
So I've left like 2 reviews in my life.
Yeah,
and I felt really, really strongly about when I did. I guess I should probably try to do that more. Yeah.
Yeah. Okay. Well, anyway, this is from JYC. And I don't know. They said, I've listened to the podcast for a few years now. And just when I think there's no more topics to cover, Pam and Kim keep coming out with more and more great topics.
Oh, nice.
I think there's no shortage of things we'll talk about.
We're not bored of each other yet.
Yeah. So one thing I most appreciate about every episode is the very personable and authentic dynamic between Pam and Kim. It feels like you're in a room with your favorite colleagues chatting about math. Aww. Just when I think I figured out 1 or 2 ways of thinking of a problem, one or both of them will each share a different perspective or way of doing things that I had never even considered. I truly appreciate how these episodes really stretch my own mathematical thinking, gives me pause to think about the intentional ways that I should structure my own instructional practices, as well as ways of lifting up student thinking about mathematics. Thank you for making each episode so engaging, inviting, and most of all, figure-outable.
Oh, that was super cool.
That's super, super fun.
Oh, thanks.
So if you have just started listening, you just wait. You'll soon find out that we mostly have our stuff together. But when we don't, we just go with it. It is what it is. We appreciate the compliment. We love chatting math with all of you too. Okay, so we have tackled the most sophisticated strategies for addition and subtraction and multiplication. So you've guessed it. Today, we're going to talk about division.
Woo! Let's do it.
Yeah.
Kim, just the other day in our message board, so we have online workshops and I interact with participants in the message board.
Yeah.
Elfie, who's taking our Building Powerful Division workshop, said, these approaches teach so many different concepts and at the same time.
Yeah.
I thought that was a noteworthy comment. First of all, Elfie, well noticed, because I think often if we are kind of stuck in that perspective that math is about rote memorizing disconnected sets of facts and mimicking rules and procedures, then, learn this, do this thing. And it's about memorizing a thing so that then you can add it to another thing.
Yes.
And that's kind of how it looks like you teach all the different concepts.
It's unmanageable.
Yeah. And it's unmanageable because there's so many different ones. And we end up with this kind of mile wide, inch deep kind of thing.
Yep.
Once you really start mathing, you really start really mathing the way mathematicians math, even at young ways, you start to realize that it's so interconnected,
Yep.
and that as you do a problem string or a routine, there are lots of things that are coming together and making more sense, which is one reason why you need more than one experience to quote unquote learn a strategy.
Mm-hmm.
I don't know if you've noticed, listeners, but I used to say things like learn a strategy, and I'm saying a whole lot more of what I actually mean, which is develop the relationships so that a strategy becomes a natural outcome.
Yep.
And it's multiple relationships. So nicely noticed, Elfie. Let's see if we can build the most sophisticated division strategy and learn a whole lot of other things at the same time.
Yep.
All right, Kim, I got some questions for you. Hey, pretty soon we're going to turn it around and you're going to give me questions, but not today.
Oh, that's awesome.
Okay, ready? What is 500 divided by 25?
Oh, that's quarters. Okay, so I'm going to say that there are 2 quarters and 50 cents.
Okay.
So like 50 divided by 25 would be 2, but you're asking 500 divided by 25.
Oh,
So it's going to be 10 times as much. So 20 quarters.
there's 20
500.
quarters in 500. For
Yep.
anybody who's not familiar with that strategy, you got anything else that we could also
Yeah.
reason about how many?
So I could think of 4 25s as 100.
Uh-huh.
So still quarters, but then I need 500s. So if there's 4 25s in 100, then I can scale up by 5 to get the 20 quarters.
Nice. 20 quarters
Yeah.
in 500. So you're saying 500 divided by 25 is 20.
Yep.
Next problem. What is 250 divided by... Oh, you know what? Before I do that, yeah, okay. I think we're good. I was trying to decide if I was going to mention something first. 250 divided by 12.5.
I also think this one is 20.
What?
Yeah. So I never say this well. I see the connection between 500 divided by 25 and 250 divided by 12.5.
Okay, what connection do you see?
So this time I am, how do I explain? This is always really tough for me. So I have a smaller, what's the word? Divisor.
Yep.
And it's half as big. And the dividend is also half as big. So my quotient, my answer is going to stay the same. So I have half as much, but I'm also dividing it by half as much.
So if you had
There's
20...
the same amount of 12.5s in 250 as there are in 25 and 500.
Say that again. There are the same amount of 12
I'm trying to find the words.
Yeah, there's the same amount of 12 and a half
in 250
as
there
twice
are
as much
in twice as much.
in
Yeah.
twice as much. Is
Right,
that a way to
right.
say that?
Yeah, those are equivalent. Right.
Okay, so if the total's 500 and you're asking yourself, how many groups would I have if I've got 25 in each group?
Mm-hmm.
You're saying I'd have 20 groups.
Mm-hmm.
And then I asked you, what if you only had half as much stuff?
Mm-hmm.
And you only had half as many groups?
Mm-hmm.
Then you're saying you'd still have the same amount of stuff in each of those groups?
Yep.
Did I say that right?
Yeah.
Can you say that?
If I have half as much stuff and half as many groups, then I have the same amount in each group.
Cool. Can you say that if it was, I have half, so 500, what if I had 25 groups?
Yeah. So I think that's the way I was thinking about it. If I have instead of 500, if I have only 250 and I have half as many what did I say backwards? I'm saying it the same way. Either I have half as many groups and the same amount in each group, or I have half as much in a group and I have the same number of groups.
Because you have the total as well.
Yeah. Yeah.
Yeah. Yeah. All right. So that's tricky stuff. We could have done that with smaller numbers to maybe make it more easy. But anyway. All right. So when you were talking, and you were talking about how many quarters were in 500, I wrote that problem first as 500 division symbol 25, but I also wrote it as 500 fraction bar 25. So like if I was describing what it looks like on the paper, 500 is over 25.
Mm-hmm.
That's not mathematical. That's just a description.
Yep.
So 500 fraction bar 25, it's almost like 525ths.
Mm-hmm.
And
Mm-hmm.
and the answer to that is 20. You were clear. The answer to 500 divided by 25
Yep.
or 525ths is equivalent to 20.
Mm-hmm.
So when you did 250 divided by 12.5, I'm also going to write 250 fraction bar 12.5.
Yep.
Another way to say that is 250 12 and a halfths.
Mm-hmm.
And you're saying that's also equal to 20.
Yes.
So if they're both equal to 20, can I write 500 divided by 25, 500 fraction bar 25, 525ths is equivalent to 250 12.5ths?
Mm-hmm.
So now I kind of have two fractions next to each other. And
Yep.
when I write those two fractions, or maybe ratios next to each other,
Mm-hmm.
525ths and 250 12.5s, I think that might be even easier for people to go, oh yeah, sure enough. If
Yeah,
you
I think so.
divide one in half, then you could divide the other in half.
Mm-hmm.
But teachers, we would suggest that you don't want to go there too fast. You don't to just
Yes, not
tell
telling. Yep.
students. Yeah, we would want to do a lot of experiences so students understand that a division problem can be written as a ratio.
Well, and some students might not have a deep understanding of the two kinds of division, right?
Yeah,
So that's some
yeah,
precursor.
absolutely. Yep. Yeah, so there's lots of precursors to what we're doing today, and we're not going to do any of them.
Right.
We're diving in, we're saying we've got those precursors, they have happened. And so if somebody can think about 500 divided by 25 like Kim did, and they have some partitive and quotative division, and they know we've done some experiences to say I can write division as a fraction ratio a
Right.
relationship,
Right.
then I now can kind of look at those equivalent
Yep.
ratios and say, like maybe we could think about equivalent ratios to solve division problems.
Yep.
I wonder if that might influence how you solve a problem like 330 divided by 16.5.
Yes, I just wrote that the way you described. So 330 fraction bar 16.5. And
Well, I
uh,
think I would like described it in the problems before. Yeah, got it. Okay.
yeah, sorry. Yeah,
Yep.
the way you were just describing how you wrote what I said.
Okay.
So I have 330 fraction bar or over 16.5, and I am making that equivalent to 660 divided by 33. I just felt like that would be an easier problem. And I
Mm-hmm.
know 66 divided by 3 is 2. So 660 divided by 33 is 20.
Interesting. So
I'm
you
totally
can.
looking at the previous problem. That's hilarious.
Why are you looking at the previous?
Because it's 20, and I didn't see a connection between those.
I'm not sure there is a connection between them. They're equivalent to 20 for sure. Are you finding one?
Hmm.
I'm not sure I meant there to be one.
Okay. Okay. Well, and
I'm looking.
now I want to play. I want to
I'm,
play.
all right,
Okay.
I'm gonna let you play later.
Okay, that sounds great.
I'm not sure I meant there to be a connection between those.
Well,
Hmm.
way to make me think a little bit. Okay.
All
Next
right,
problem.
next problem. 76 divided by 8.
76 divided by 8. Okay. I actually like the divided by 8 because then I can just say that the 76 divided by 8 is equivalent to, what is that, 38 divided by 4? Yeah.
Because
Half of 70 is 35 and half of 6 is 3. So then I know that that's
so you were
38.
having 76. That's
Yeah.
what you're
Sorry.
you went straight to telling us how you're having.
Oh, I'm sorry.
So if you have
I'm
76,
having both those numbers to make
okay.
38 divided by 4. Thanks for slowing me down and
So it's
describing.
like you found an equivalent
I
problem.
forget you can't see my paper. Nobody can
It's
see my
true. I
paper.
can't. Yeah, no one right now can see your paper. Okay, so you have 76 divided by 8 is equivalent to 38 divided
38
by
divided by
4.
4. Yep.
Okay. Uh-huh.
And then I'm having those again, and I'm saying it's equivalent to 19 divided by 2,
Okay.
which is equivalent to 9 and 5/10, 9.5.
9.5. 19 divided by 2 is 9.5.
Yep. Yep.
Sweet. So in the previous problems, I kind of felt like you scaled up both
Yeah, the last problem I sure did.
the 330 divided by 16.5. You
Yep. Scaled up.
doubled both the numerator and the denominator.
Yep.
And this time you scaled down. You divided the numerator and the denominator. So that's interesting. So you could do either of those to find an equivalent division problem that's easier to solve.
Mm-hmm.
Cool. How about 36 divided by 144?
Mm-hmm.
That's a crazy
I'm
problem.
writing that like a fraction. So 36 divided by 144. I noticed that they both have a 12 in them.
Mm-hmm.
So 36 is 3/12s, and 144 is 12/12. So I'm scaling that down by 12 to get 3/12, which I know is a fourth.
Bam. So you're saying 36
Yeah,
divided by 144 is one
it's
fourth.
nice. I like that
And
problem.
thank you. And if you had seen that problem as 36 inside the housetop and
Oh
144
gosh.
outside
Oh,
the
do
housetop,
I even know how to do that anymore? I don't know.
I hope
Probably
not.
not.
Do you agree with me that after all of that work, you would have ended up with 0.25?
Yes. Mm-hmm.
Does that make sense?
Yep.
So, knowing that we can think about division as in all with all those precursor things that we talked about, but also as a ratio that you could then find an equivalent ratio could be really slick to
Mm-hmm.
find. Not only slick but understandable, right? A clever way of doing problems like 36 divided by 144.
Yeah.
How about 49 divided by 0.5?
Oh, I'm going to scale that up to something divided by 1. And so I'm just doubling 49 and the 0.5, and that's 98 divided by 1.
I will never forget the day when I was working with this equivalent ratio strategy. Could I turn a division problem into a ratio, find an equivalent ratio that's easier to solve? When it occurred to me that anything divided by 0.5, I could scale both the divisor and the dividend, the numerator and the denominator, to something divided by 1.
Yeah.
Bam!
Yeah.
So nice. And so much work with the long division algorithm. So much work. Okay, next problem. How about people are like right now trying all sorts of problems divided by 0.5. They're like, really?
Should we pause a little bit? Let them
Oh,
do some more
well, I
thinking.
mean, they can pause the podcast. Nope, we're moving on.
Moving on.
0.88 or 88 hundredths divided by 0.25. Oh, Kim, decimal division. We've got decimals everywhere.
Mm-hmm. Mm-hmm.
Crazy. There's no way you can think and reason about this one.
Well, I'm going to go with your divided by 1 again. So I'm going
You,
to scale those numbers up by 4
ooh,
so that I can do 88 hundredths times 4 and a quarter times 4.
a quarter.
And
That quarter times 4 sounds really nice because now you're
yeah,
divided by
that's good.
1.
Mm-hmm.
88 times 4.
Mm-hmm.
What are you doing to do that?
I'm going to go with 90 times 4 is 360, 3.6. And that's too much by 2 cents. So 2 cents 4 times. So it's 8 cents too much. So I'm getting 3.52.
3.52. Like it's kind of like that 360 minus 8 was 352. And then you kind of put that's how I did it and put the
Yeah.
place value back in.
Uh-huh.
All divided by 1.
Mm-hmm. So
Which,
3.52.
so you're saying that 0.88 divided by 0.25 is 3.52.
Mm-hmm.
Nice. And if you were to kind of reason about that, are there about 3.5 quarters in 88 cents?
Yeah.
It's kind of a way to kind of check and make sure our magnitudes made sense. I do not think I would have to scale times 4. I think I would have. So when you decided 0.25 times 4 is 1, let me just scale the 0.88 times 4. I
Mm-hmm.
think I might have doubled.
Oh, okay.
But
Yeah.
I like how you did the times 4. Taking a drink of my tea. All right, next problem. Are you drinking anything today?
Water, but I'm almost out.
I'm drinking throat coat tea, herbal tea. I'm an herbal tea drinker.
Hmm.
Anyway, you don't care. Moving on. How about 1 point? I don't know why I went there because I was worried I was taking too long drinking and my throat is sore today. Last problem of the string. What is
All right.
1.6 divided by 0.125?
Okay. So I know some
Hey,
stuff about 0.125, but I'm
yeah,
gonna pretend I don't.
can I ask you something really quick first?
Sure.
Could we just estimate, is this answer going to be less than 1 or more than 1?
Less than 1 or more than
Because it's
1.
kind of this ugly fraction with all these decimals, and I'm just kind of curious.
It's gonna be significantly more than 1.
How do you know?
Because you're dividing 1.6 by an eighth. So it's like how many eighths are in 1.6? It's kind of what I'm thinking about.
So you know something about 0.125
Yeah.
being an
Yeah.
eighth. Okay. All right.
But basically, I mean, another way to think about it is I'm going to scale up quite a bit what I'd like to do is make it be something nice in the denominator, and I'm going to
Mhm.
have to scale up to make that happen. And so my numerator, when I scale it up, is going to be larger.
Okay, then the denominator.
Mm-hmm.
Yep. All right. And as it started out that way, right? The numerator is larger than the denominator.
Yeah. Yeah.
Okay, keep going.
I know that it's times 8, but I'm feeling like maybe I'm just going to double.
Okay.
So I'm going to call that 3.2 divided by 0.25. And then I'm going to double it again to get 6.4 divided by half. And then I'm going to double again to get 12.8 divided by 1. So my answer is 12.8.
Bam. Isn't it cool when you get to a place
Mm-hmm.
where the question is the answer? What is
Mm-hmm.
12.8 divided by 1? I don't know if the
Yeah.
question's the answer, but it's
So
so
nice.
like, padum, we're done. Yeah.
Mm-hmm. Mm-hmm. Mm-hmm.
So we call this the equivalent ratio strategy.
Yep.
Can you turn a division problem into a ratio and then find equivalent ratios that are easier to solve? And we would suggest that this is the most sophisticated division strategy that we're going to try to help students develop the relationships to make this strategy become a natural outcome. All right, Kim, here's your quiz.
Oh.
What is one way, one thing that could ping? Why are we calling this? What's a thing that's true about the equivalent ratio strategy that makes it a most sophisticated strategy?
There is some anticipatory thinking, right? You have to think about what's going to happen with maybe both of the numbers to decide if this is a strategy that makes sense to be using for these numbers.
Which also means that you are considering things simultaneously.
Yep.
All right, if I turn this into a ratio, does it make sense to scale the numerator and the denominator to something that will, so I'm simultaneously considering the kind of strategy I'm using, both
Mm-hmm.
the numerator and the denominator, and the key to all of these sophisticated strategies is that they're also equivalent strategies, that
Yep.
you're also considering, can I make an equivalent problem that is actually easier to solve? And so then also developing equivalence at the same time. So three major kind of hallmarks that we're suggesting are: are you considering things simultaneously? Are you using anticipatory thinking? And is it an equivalent strategy? And when those three things come together, we think it's a pretty sophisticated strategy.
Yep.
Nice. So how do we model this one? This is maybe how do I say this? We could say how we modeled it today, and also then I want to back up and how we would actually develop the strategy.
Yeah, I think you maybe described a little bit about what was on your paper. And mine was the same. So when after the first problem, when I was thinking about quarters,
Mhm.
then from that point on, I represented with equations, but in a fraction bar kind of
Notation.
way. Yeah.
Yeah.
Hmm.
Yeah.
Yep.
So if you look at my paper, you would see a lot of fractions with equal signs in between,
Yep.
a lot of equations with a lot of fractions with equal signs. Is that
Yep.
a way to
Yep. Mine
describe
too.
that?
Hmm.
Yeah. I think the only time that I kind of did something slightly different is when I wrote the long division housetop, when I was talking about what it would
Oh,
look like. But
yeah.
everywhere else, I've just got
Put a big X on that, man.
well, except we can write division using that symbol. It doesn't mean that then we have to follow
Yep.
steps. It just means now divide. And
Yep.
oh, hey, how about if we divide actually thinking and reasoning?
Right.
That's a big.
I think that's a really good point because actually somebody recently asked, at what point do we, gosh, might have been Christy in Journey. I think maybe she said something like, "Hey, at what point my teachers are going to ask about fraction division notation?" And
Mm-hmm.
we had a chat about all the different notations there are. There are several, and kids need to see them all, and that doesn't dictate the way that they solve it.
Nicely
Right?
said.
Yeah.
Yeah, nicely said. And since this, oh wait, so sorry. But I was going to move on to something else. But if I was developing this with students, and I think we can start developing this in fourth grade and then continue in fifth grade.
Hmm.
A thing that we would do in fourth grade is what Kim and I affectionately call the bigger, smaller thing.
Uh huh.
So
Yep.
if I had something like 32 divided by 8, I might think about if I had $32 to share among 8 kids, we would discuss that. And then I might say, well, then how does that relate to something like 16 divided by 8? And Kim, if we were talking, there's not an equal sign in between those. But if I said $32 divided among 8 kids, now we only have $16 divided among 8 kids. How would you reason about how much money each kid would get?
They're each going to get half as much because you have half as much total.
Yeah, the total was halved, and you had the same number of kids. So they each get half as much.
Uh-huh.
But what if I said from the 32 divided by 8, I've got still that $32, and now you're going to divide it among 16 kids.
Poor
How do you reason
kids.
that one?
They're going to get half as much.
Because
Because there's twice as many kids.
yeah, and the total stayed the same,
Yeah.
right?
Mhm.
So that needs to happen in fourth grade. There needs to be
Yep.
this conversation about this bigger, smaller, and how things relate, so that then in fifth grade, we can do things like, if I start with those $32 divided among 8 kids, and then I double the money to $64 and I double the kids to 16,
Mhm.
could you use 32 divided by 8 to help you think about 64 divided by 16, or even double that again,
Right.
128 divided by 32? That's a little bit more of a, like, kids would have to think about that problem. But if they can say, well, if I had $128 shared among 32 kids, well, if I halved the money and halved the kids, I could do that again, halve the money and half the kids, I end up with 32 divided by 8. Bam, that's a problem. Kids should be able to, well, they might be able
Yeah.
to think about 64 divided by 16 as well. And they
Yeah.
could also then think about 16 divided by 4, right? Like,
Yep.
they could keep finding equivalent ratios. So we would really then want to develop that in fifth grade. But also, I'll just mention, I would also do some work with area models
Yeah.
to talk about what happens when the area stays the same and the dimension halves. What happens when the area halves and the dimension halves. And I'll
Yep.
just sort of raise that, and we could talk about that more some other time. Cool. Since this is an equivalent strategy, it's in the name, it's equivalent ratio. Since it's an equivalent strategy, we can also do relational thinking with this strategy to help sharpen kids' thinking about sharpen their thinking about equivalent ratios. So, Kim, use relational thinking to solve this problem. It looks like 21 fraction bar 3.5. So 21 3.5ths. I don't know how to say that, but 21 divided by 3.5, but in a fraction ratio notation, is equivalent to 42 divided by blank. 42 fraction bar, and the blank is in the denominator of that fraction. Okay.
Yep. So instead of 21 divided by 3.5, I'm going to scale that up because I want to figure out the relationship between 21 and 42, and it's doubled. So 3.5 doubled. I just wrote 6 is 7.
So 21 divided by 3.5 is
Yep.
equivalent to 42 divided by 7.
Yep.
Which is also equivalent to what? Your 6.
6.
Right? Your 6 was screaming at you.
Yep.
So much so that your
My
hand just
pencil
took over
Yep.
over and wrote 6.
Yep.
Yeah, cool.
Yep. So, hey, y'all, check out the relational thinking problems that you can take back to your classroom and use right away at mathisfigureoutable.com/relational dash thinking. It'll be in the show notes. They're fantastic. And while you're there, peruse around. There's a bunch of great stuff in that instructional routines hub, all there free for you.
Absolutely. Yeah.
Okay. Also, we would highly recommend that if you want to learn more about the equivalent ratio strategy, we've actually talked about this before on some other podcasts. That's episode number 64 and 132. There's some fantastic nuggets there that you can learn more about this particular strategy.
Super cool. All right, y'all. Thank you for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Thanks for helping spread the word that math is figureoutable. Thank you for listening and making math more figureoutable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figureoutable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.